All right, hello. Welcome, folks. We are now on to chapter 3 on measures of dispersion and variability. So if you have not yet read Salkind chapter 3, stop this now and read through chapter 3. I will tell you this is one of the more challenging lessons that we do this semester. Trust me, you're going to be okay. We're going to get through it. You will feel proud of yourself at the end, but this is definitely one that it helps to at least glance through the chapter before looking at the lesson. It's going to make things go much more smoothly. So also make sure that you have the lesson handout for chapter 3, the lesson outline, printed out if possible. This is one that we're doing a lot of steps for calculations by hand. It's really helpful if you have the lesson handout printed out, or at least have it up on your screen to be typing into, with a separate sheet of paper ready to be practicing some of these long steps by hand. Okay, so if you've read the chapter, you have the lesson outline ready, let's go. So variability is all about how values in a data set differ from one another. So this is another way to think about this is how different each value in a data set is from a particular value, such as the mean. So for example, if you have a set of values, how spread out are they away from the mean? Are values all really close together, close to the mean, or are they all really spread out? So other words for variability include spread, how spread out the values are, or dispersion, how dispersed are the values. So if we think back on chapter 2, measures of central tendency are really about how similar values are, right? What's the one value that best summarizes all values? And variability does the opposite. Variability is measuring how different values are from one another. So if we're thinking about how to display this visually, what I mean by variability is that here's 3 different sets of data, right? 1, 2, 3 sets of data. They all have the same mean of 5, but their variability or their spread is really different, right? These values, even if you know nothing yet about how we're calculating different measures of variability, just visually looking at these, we can say, okay, this first one is pretty spread out, right? That this has more variability than these other ones. This one has less variability in the middle, right? They're all kind of close together. And then this one at the bottom has no variability, right? They're all the same value. So all of these have the same mean of 5, but we can also think about another way to describe data is not just the mean, not just the average, but also how spread out they are, how different are the numbers from one another. So after this lesson today, you're going to know the 2 most helpful ways to describe a set of values, right? We did last week in chapter 2, the average, mean, median, and mode. And then today we're going to learn 3 measures of variability: range, standard deviation being the big one, and then variance is one that I won't ever have you calculate, but that I want you to know that it exists, because you'll probably see it come up in your academic career in journal articles at some point. So these are the 2 key values for describing interval level data. So last week when we did chapter 2, we knew that we used mean and median for interval level variables, and then mode was used for our categorical variables, our nominal and ordinal variables. Variability, though, only applies for interval level variables. So there's no measure of variability for categorical variables, for nominal and ordinal. So this chapter 3 is on variability is totally only about interval level variables. Okay, how and why are these helpful? So let me give you an example here, right? Let's pretend you have a friend from out of town who wants to know where he should take his date. He wants to know where he's likely to have the lowest bill. He doesn't really care about this person yet. Which place would you recommend to him and why? So he could either go to Caitlin's place that has the prices listed here for 5 different dishes, or you could go to Taylor's Cafe that has the prices listed here for 5 different dishes. On one hand, we can say, what's the average price at each of these? Both places have a mean, though, that's exactly the same. If you take a pause and want to do a little practice of calculating the mean for each, if you add up all of the values and divide by 5, both of them come out to $11. So both places have a mean of $11. But is there one place that we think would be a better recommendation for him based off of where the lowest bill is likely going to be? And variability can help us in doing this by being able to say, okay, is the set of values more spread out at Caitlin's Place, or are the values more spread out at Taylor's Cafe? The easiest or most straightforward way to calculate a measure of variability is using a measure called range. And range is just a really general estimate of how spread out or different scores are from one another. And it only takes into account the highest value and the lowest value. So to calculate the range, you're just subtracting the lowest score from the highest score in your distribution, in your data set. So the formula for range is R equals the range. This is the range equals the highest score or the highest value in the data set minus the lowest value in the data set, right? So this is really just a straightforward idea about what's the distance between the highest value and the lowest value. And if we could calculate the range for Caitlin's Place and for Taylor's Cafe, right? So here the values are already conveniently listed in order with the highest values on the left and the lowest values on the right. So our formula again for range is R equals the highest value minus the lowest value. Here our highest value is $20, our lowest value is $5. So we calculate our range for Caitlin's Place as $15. Doing the same for Taylor's Cafe, our high value is 40, our low value is 2. 40 minus 2 gives us a range of $38 for Taylor's Cafe. So now we can tell our out-of-state friend, well, they both have the same average price, but Caitlin's Place has values that are kind of closer together, closer to that mean, whereas with a larger range, the values are a little more spread out, right? There's a better chance that the date could pick some really high-priced meal at Taylor's Cafe compared to Caitlin's Place, right? So range is just a really straightforward summary of how spread out the values are using just the highest value and the lowest value. And so the real limitation, though, or the weakness of using the range, the downside is that it only takes into account the highest and the lowest value, right? So what if we have two sets of values like this, right? This first one is 100, 80, 60, 55, 30, 25, 10. This other one here on the bottom is 100, 190, 85, 85, 80, 10. Both of these have a range of 90, right? 100 minus 10 is 90, 100 minus 10 here is 90. But just visually looking at these, you can see that one is definitely more spread out than the other, right? This first one has values that aren't all smushed together towards the high end, whereas this one, the values are kind of less spread out, right? The most of the values, with the exception of 10, are above 80 and 100, but here there's an 80, a 60, a 55, a 30, a 25, right? So that just even visually looking at this, these two data sets have the same exact range, but we know that that's not perhaps a tell-all type of measure of how spread out the values are, because it only takes into account the highest and the lowest values. Okay, so what's another option? Another option is to use a measure of of variability. Our second measure of variability is called the standard deviation. And this is the most frequently used, most important measure of variability. The standard deviation looks at the average amount of variability in a set of values by calculating what is the average distance of each value from the mean. So that if there's a number that's larger, a higher standard deviation means that on average, each data point, each value is farther away from the mean. So think about this as a bigger standard deviation equals more variability. A bigger standard deviation equals more variability. A smaller standard deviation means less variability, that on average each value is closer together. To give a visual representation of this, to how to kind of conceptualize what standard deviation measures before we go through all of the steps to do so, let's say I had this data set with values of 1, 5, 9, 14, 23, 38. Add all of those up, divide by the 6 values there are. This gives us a mean of 15. Remember from last week, X bar is our mean. This is our mean of 15. So among this set of 6 values, 15 is our mean. What standard deviation does is looks at how far is each value in the data set from the mean. How many points away is 1 from 15? How many points away is 5? How many points away is 9, et cetera, et cetera? And what is the average of all of those distances? So it's saying, on average, how far away is each value from the mean? Standard deviation looks at, on average, how far each value is away from the mean. So instead of just looking at figuring out variability based off of just the lowest value and the highest value, standard deviation says we're going to account for every value to measure variability by saying how far is each value from the mean. Okay, now this next part looks scary. Everyone take a big deep breath. I'm going to take a big sip of my coffee. This is probably the calculation that we use the most steps for the entire semester. So once we get through this, and I promise you're going to get through it, then you're going to feel really great and know that the worst is over. Okay, so this is the formula for calculating standard deviation, and I'll talk through each of these steps with you. Okay, so remember, let me kind of first just review some of the statistical notation, and then we're going to break down each part of this formula into the different steps. So first, this S stands for is the statistical notation for standard deviation. Remember, we learned in the formula last week for calculating the mean, this funky looking E is the sigma, right? Sigma tells you to sum or to add up everything that follows it. X, remember, stands for each individual score or each individual value. And X bar, remember, is our mean. N is the sample size, is how many values we have in the data set. Okay. First step, and make sure you have a piece of paper on the side. Remember, I know I've talked about before that there's some actual magic that happens from watching and listening and then it going through your brain, through your hand, and onto the paper as the most effective way to learn to do this. So please don't just sit here and watch it passively. Have pen and paper out and be writing this down, doing the steps along with me, just like you would be doing if you were taking notes in a live classroom with me. Okay, so first step to work through this formula is to set up this chart. And you're going to create 4 columns in this chart. The first column is X, the second column is X bar, third column is X minus X bar, and the fourth column is X minus X bar squared. And when you're doing this on just line paper, you don't really need to set the number of rows ahead, but just as a FYI, you'll have one more number of rows than there are number of values in the data set. Okay, so we have our 4 columns set up. Let's look at, I'm going to highlight each part of this formula so we know which part we're working through for each step. So the first 3 steps are taking into account this yellow part here, this X minus X bar. So step one is going to be to list each score in that X column. Step two is going to be to calculate the mean for each value. And then step three is going to be to subtract the mean from each score in column three. So let's look at what that looks like. So here, your first column, these would be the data that I already give you, right? So I'm going to say, let's calculate the standard deviation for, let's say these are, I don't know, drink prices. For these 6 drink prices. $12, $10, $8, $5, $4, $3. So your first step, step one here, is to list each score. Here, order does not matter. They don't need to be high to low, low to high, it doesn't matter. List each score in this first column. That's all of your X's, right? These are the data that are given to you. So step one, list all of the values. Step two is you're filling in the second column with the mean. So you're calculating the mean for the data that are given to you. Add 12 plus 10 plus 8 plus 5 plus 4 plus 3 and divide by 6 because there's 6 different values. And that gets you 7, a mean of 7 for column 2. Step three, remember back here, is we're subtracting the mean from each score, right? X bar is the mean. We're subtracting that from each score. So here we're subtracting 12 minus 7, our X minus X bar. 12 minus 7 is 5. 10 minus 7 is 3, 8 minus 7 is 1. And here, as you're doing column 3, negatives matter. So always be careful to be doing the X minus X bar. Negatives matter. So here, 5 minus 7 is -2, 4 minus 7 is -3, 3 minus 7 is -4. Helpful tip to be checking your math at this point. Your column 3 here should always add up to 0. Your column 3 should always add up to 0, or when we start doing more complicated problems that sometimes these come out to decimal points, if because of rounding, you might be at like 0.2 or 0.1 or something like that, right? But you should always be close to 0 here. And if you've done no rounding with decimals, then it should be exactly 0. That's a helpful way at this point to check on your basic arithmetic. And as you will learn throughout the semester, I am guilty as anybody else of making what I call the fat finger calculator errors. So always having a check on your arithmetic is helpful. Okay, so recap. So far, we've gone through this part, this yellow highlighted part of the formula. We've listed all of our X's for step 1. We've calculated the X bar for column 2, and then column 3, or step 3 here, is our X minus X bars. Okay, what next? Step 4, now we're breaking down this part of the formula, is the square part. We're squaring each individual difference from step 3. And then step 5 is we're going to add up or sum up. Remember, the sigma means add up everything that comes after it. Add all of those up. So now we're filling in column 4 by squaring everything from column 3, right? This is column 4 is the exact same thing as column 3, plus with the addition of the square here, right? So that means we're taking 5 times 5 is 25, 3 times 3 is 9, 1 times 1 is 1. And here, as you square something, this will be getting rid of the negatives, right? Because a negative times a negative is always a positive. So you should never come out with a negative number in column 4. -2 times -2 is 4. -3 times -3 is 9. -4 times -4 is 16, right? So now we've just worked through step 4 is filling in column 4, right? We've done this squaring all of our X minus X bars. Step 5 then is adding up all of our X minus X barred squares. So after we filled in column 4, then we add up this column. We add 25 plus 9 plus 1 plus 4 plus 9 plus 16, and that gives us 64. So now this gives us this top part, right? After working through step 5, this gives us our numerator of 64. So let me kind of go back and recap these last couple of steps in case it's helpful. So first step is to list all of the values. Step 2, calculate the mean. That goes in column 2. Step 3 is subtract the value in column 1. Subtract the value in column 2 from column 1. So 12 minus 7 equals 5. Step 4 is to fill in column 4, in which you are squaring everything in column 3. So 5 times 5 is 25, 3 times 3 is 9, etc. Step 5 is to add up everything in column 4. And that gives you this top value here, this sigma x minus x bar squared is what where this 64 goes. So now we're filling in, continuing our formula here where s equals the square root. We just did this by doing our little chart, right? That's where our 64 goes. Now to fill in the yellow highlighted part is our n minus 1. So n is the number of values we have. Remember, I've given you 1, 2, 3, 4, 5, 6. Ooh, that's an error. Oh, sorry, not an error. I was worried I wrote 5 here at first. Well, I've given you 6 values, 1, 2, 3, 4, 5, 6. Our n is 6. So we fill in on the bottom, 6 minus 1. That's this highlighted part. Step 6 is identify what your n is and put that on the bottom, minus 1. So now you're just going through and solving the math on this. The 64 divided by 5 and take then the square root of that is step number 7. So step number 7 here is I have this yellow highlight, and the step for this is to do the square root. So we've gone through down here, 64 divided by 5 is 12.8. Take the square root of 12.8 to get 3.58. A helpful tip is if you are doing the calculations on your phone, especially if you have an iPhone, if you're holding your phone vertical in normal way, portrait mode, you only have a limited number of buttons, right? You don't see the square root symbol. But if you turn it horizontal, if you turn your phone horizontal in landscape mode, turn your phone horizontal, then you will see the button that has the little 2 and the square root X symbol. That's your square root button in the iPhone. So it's, if you're looking in the iPhone, it's the second column from the left and the one in the middle, the third button down. So if you have trouble finding that, send me an email, or maybe I'll do as a separate video on that in case people have trouble. Okay, so the last step of computing standard deviation and then is doing this square root that gives you then a standard deviation of 3.58 as your final answer. Okay, it's okay to be like, oh my gosh, I'm totally overwhelmed. That's a crap ton of steps at this point. Trust me, we'll have lots of time to practice. We'll do a practice at the end of the lesson today all together. Then you'll have a couple of opportunities to practice in the classwork as well, so that you will feel like a rock star of calculating standard deviation by the time it's the end of the week that you have to give me the homework. So as always, I will say during the lessons, I don't expect you to feel confident after seeing it for the first time. Statistics is an exercise that takes practice. So know that's a lot of steps, but you're going to feel good about it soon. Okay, I want to say just a couple of things about the kind of methodology or the rationale behind the steps. If you are the type of math learner that is like, I don't need to understand how things work or why this works, just tell me the steps and let me follow the instructions step by step to get it, and that's what works for you, that's fine. If you are, and if you are in that category of I don't need to know how it works, just tell me the steps, feel free to kind of turn your ears off for this rationale part. However, if you are the kind of learner that's like, I need to understand how and why something works for me to be able to do the steps, then this part is for you. So why do we not just add up all of the deviations from the mean, right? So if the idea behind standard deviation is we're measuring on average how far every value is from the mean, why don't we just add up everything in this column, right? This is all of the how far is each value from the mean. That's what these values are. But the problem with doing this is if we were to just add all of this up and divide by the number of values there are, we're always going to have 0, because with these negatives, this always equals 0, right? Because we have the mean is this idea of the seesaw, that there's the number of values is equal on each side. This is always going to come out to 0. And so the reason then that we square all of these values is to get rid of these negatives. We kind of then later undo that square by doing the square root, right? So we square it to get rid of the negatives and then do the square root to put it back into the original values, if you will, or the original scale. So that squaring the deviations gets rid of the negative signs. So when everything is summed, it doesn't just add up to 0. Then another important rationale is, why do we divide by n-1 instead of just n, right? So normally when we calculate a mean, when we figure out what is the average of something, we just divide by n, right? We divide by the number of values there are. Why do we do n-1? And the short answer here is we want to be a little more conservative about our estimate. So this is forcing the standard deviation to be larger than it would be if we didn't do n-1. We want to err on the side of caution in statistics, and this is important because we're often just using a sample with a smaller n in order to make estimates about a population. And so if you look at, if you're one of these people that I need to know how it works in order to be able to do the steps, make sure you look at the table on page 49. Really illustrates this idea of being conservative. It shows that as the sample size gets bigger, there's less difference between what they call the biased and unbiased estimate. So the unbiased estimate would be the just dividing by n, or the biased estimate would be the n-1. So that this becomes less of an issue, right? As the sample size gets bigger. If your n is 10,000, doing 10,000 minus 1 changes your final answer less than if this n is 10 and you're doing just 10 minus 1, right? So that the n-1 is kind of helping us take into account sample size, if you will. Okay, and again, about these past 2 slides on the rationale for the steps, if you are the kind of learner when it comes to math that you're like, just give me the steps and let me do each of the steps, and that's what works for you, you don't need to worry about the rationale. But if it's helpful for you to be able to understand why we do certain things for the steps, then these 2 slides are for you. Okay, so recap the measures of variability we've done so far. Our range is just what's the distance from the highest value to the lowest value. Standard deviation then takes into account every value by saying, on average, how far is each value from the mean. The third one, I'm not going to ask you to ever calculate. I just want you to know it exists and what it measures, because you will see it becomes more important in really advanced statistics. So it's likely that if you're ever reading like a peer-reviewed journal article for another course, or as part of your regular life, which I hope you start consulting peer-reviewed journal articles for questions in your regular life, it's likely that you'll see this statistic called variance. And so I just want you to know what it is. And 50 soda drinkers and asked them all to say what's their favorite soda, we could write in a survey of 50 regular soda drinkers, Pepsi was the modal category. So you're always including the N and the name of the mode, the modal category. Okay. I'm going to pause here and then do this as a separate recording for the practice. So stay tuned for that. The next recording will have a practice for calculating range and standard deviation, as well as then how to do all of this for variability in Excel. So that'll be a separate one.